Hello, fourth graders. This is Mrs. Nagy, and we are about to learn math lesson 94, which is about two-step problems about a fraction of a group. So I'm excited to get into this today. What I need you to do, first of all, I want you to look at the new concept. It says the word problems in this lesson are two-step problems involving fractions of a group. First, we divide to find the number in one part, then we multiply to find the number in more than one part. So if you read over example 1 and example 2, then you will kind of start to see how what we're going to do is diagram, so draw a picture to break up a larger group into smaller sections. As you see in example number 1, let me see if I can actually show you in this little bit of my book. So I'm talking about when you take a bigger number, like right up here, it says 30 campers and it's broken up into thirds, 10 campers, and another 10 campers. And if I say 2/3 of them wore green jackets, well, you know that's 10 plus 10, right? So you would multiply 10 times 2. So first we take the 30 campers, divide it into 3 to get 10 campers. And then if we want to know about 2/3 of them, then we say, oh, 2 times 10, and so on. So I want you to read example 2 and example 3, which I think is very self-explanatory and you will understand it. And then we're going to jump right into our lesson practice to give us 3 new examples that are not all just easily written out for us, so you can see what we're talking about. Okay, so starting off with, again, it's math lesson 94, two-step problems that we're going to first divide and then multiply. That's the point of this lesson. Okay, so letter A, we are in lesson practice. We are on page 624. And we are jumping right into letter A. Okay. Letter A says, diagram problems A and B, then answer the question. When they're talking about diagramming, we're talking about the same thing as I just showed you on the page before, where we had the 30 campers divided into that box with 3 different parts. So this time, it says 3/4 of the 24 checkers. Checkers is a type of game that we use on the same type of board as chess, in case you're not familiar. So 3/4 of the 24 checkers were still on the board. How many checkers were still on the board? Okay, so this game has 24 pieces, and it's said to diagram letters A and B to figure it out. Okay, so there we go, 24 checker pieces. We're going to draw a little box, and it said 3/4, which means we need to divide this into 4 equal parts. Okay, and then we need to figure out what each of these parts, how many checkers would be in each of those parts. So first step is to say 24 divided by 4. I just put this 3/4 up there so we remember that that is how many are still on the board. So we're going to need to know this much of it. So 24 divided into 4 equal parts is 6. 6 times 4 is 24. And that's it. So we know, and you could have, maybe you already thought of this mentally and it was no big deal for you. 6 checkers go into each of these boxes. That is how we're going to diagram it. So 6, 6, 6, and 6. Checkers, checkers, checkers. Okay, so what's 3 out of those 4? Well, let's see, we're going to say 6 times 3 is 18. Okay, so if we want to know what 3/4 are, this is 3 out of 4. This last piece is 1 out of 4. So 3 out of 4 is this 18 checkers. Okay, so as I told you a minute ago, in these problems, we're going to have to divide first and then multiply. Okay, let's go ahead and try letter B. Letter B says 2/5 of 30 students. So it's the same idea, except this time we're going to look for 2 out of 5 parts. So 2/5 of 30 students studied more than 1 hour for a test. How many students studied for more than 1 hour? So you need to find out, well, what is 2/5 of 30? Okay, of 30 students to be exact. So B. Okay, so we're looking for 2/5 of 30 students. Okay, are you with me? I hope you're with me. Okay, so how would we diagram it? We're going to write down 30. We're going to draw a box underneath it, which will be broken up into 5 equal parts, which means 4 tallies. Add 4 tallies to break into 1, 2, 3, 4, 5 equal parts. And we are going to want to know 2 of those 5. Like add those 2 together or multiply by 2. Okay, so first thing is, what's 30 divided by 5 parts? 30 divided by 5 is 6. 6 times 5 is 30. Done. So we know if we're dividing 30 into 5 parts, it's going to be 6. And 6 and 6 and 6 and 6. 6 times 5 will give us that 30. Now, here's the multiplication part. 2 of these 6s. 2 times 6, or 6 plus 6, if you want to do addition, is 12, right? So the idea is that 12 of these 30 students are the ones that studied for more than an hour. So 12 students, and you want to write that, 12 students is the final answer. Now, can you write 12 students studied for more than an hour and make it even clearer? Yes, please, and thank you. But for lack of time, as long as you have the label students, it'll make sense to me. That's all that's really necessary. And then lastly, we have letter C, which says the force of gravity on Mercury is about 1/3 the force of gravity on Earth. Remember, we had a lesson about this a long time ago, about mass and weight. And we said that the weight can change depending on the gravity of where you are, but your mass does not change. Okay, so tire would weigh something different on the planet Mercury, but it would have the same mass. It's still the same tire, it's still the same stuff. Mass is about the amount of stuff. Okay. Weight is about how its gravity is pulling on you and what would show on a scale how much you weigh. Okay, so that means in letter C, same page, we're talking about a tire that weighs 39 pounds on Earth. 39 pounds is this tire, but on planet Mercury, it would weigh 1/3 of that. So can we use a diagram again? It didn't tell us to, but we certainly could. So the first part will be to say 39. Whoops, I almost did a multiplication. Okay, 39 divided by 3. 1 times 3 is 3, and you subtract, bring down the 9. 3 times 3 makes 9, and we subtract 9 minus 9, which gives us 0, and we're done. There's nothing else to bring down. That's 13. So 13 pounds plus 13 pounds plus 13 pounds gives us 39 pounds. Now, did that completely answer the question? Well, let's check. The question was, how much would a tire weigh on Mercury if it weighs 39 pounds on Earth? So the answer is the tire would weigh 13 pounds. Remember, it said 1/3, so we're talking about just 1/3 would weigh 13 pounds. And there you go. 39 on Earth, 13 on Mercury. All right, and that's really the gist of what we do with some of these problems when it tells us to find 1/3 of something or 2/5 of something or any fraction amount. Okay, we break it up into equal parts and then we multiply by however many it told us we need, like 2 out of 5 or whatever. Okay, so that brings us to our first star problem, still on page 624, but not lesson practice anymore. Now we are on number 3. Number 3 says Dewan is 2 years older than Rebecca. Rebecca is twice as old as Dylan. Dewan is 12 years old. Ooh, first given information. How old is Dylan? First find Rebecca's age. Okay, so let's see. I have to think about this. I haven't done this problem. So let's see. We have somebody named Dewan, right? I think I spelled that wrong. Is 2 years older than, what was the other name? Rebecca. 2 years older than Rebecca. Oh, running out of room. Next we have, so think about that. Dewan is 2 years older than Rebecca. Now Rebecca, Reb, I'm going to call her, is twice as old as Dylan. So it's twice whatever Dylan's age is. Okay. Now we find out that Dewan is 12 years old. Okay, so there we go. There's the first actual thing that we know for sure. Dewan is 12. Thank you very much. Then let's see. How old is Dylan? And it says first we find Rebecca's age. Well, it told us right here that Rebecca is twice what Dylan is. Okay. How old is Dylan? Well, whatever Dylan is, Rebecca is twice as old as him. We also know that Dewan is 2 years older than Rebecca. Okay, so Dewan is 2 years older than Rebecca, so then how old is Rebecca? Well, let's write down what Rebecca is. If Dewan is 2 years older, that means Rebecca is 2 years younger than 12. So Rebecca is actually what? I would say that she's probably 10. And then it says Rebecca is twice what Dylan is, which would tell me that Dylan is what? 5. Dylan would be 5 years of age. Would you agree? I would think so. So then what we need to write at the end is Dylan is 5 years old. Make it very, very clear. Okay. Okay, make sure you get all that down. And I'm going to assume you can pause and I will go on. So our next star problem is number 5. Okay, so let's see. Number 5. Oh, again, it's a lesson 94 problem, so it's like our lesson practice problems. Number 5. A. There's an A. It has more than one part. 3/4 of the 84 contestants guessed correctly. How many contestants guessed incorrectly? Oh, I said that wrong. 3/4 of the 84 contestants guessed incorrectly. So how many was that? Draw a picture. All right. So first things first, we're going to make a box. We are going to write that there's 84 contestants at the top. Next, we are going to break up this box into the fraction amount that was given. And it said 3/4, right? Which tells me that there's 4 equal groups. So when I cut something into fourths, I cut straight down the middle and then cut the other 2 right in half. Okay, so if there's 4 equal parts, there's 84 total contestants, which are people in some sort of contest. Okay, then I first have to do this. I'm going to have to divide 84 divided by 4 so I know what each of these are equally. And then I'm going to have to multiply it by this. So divide it by 4 and multiply it by 3. Okay, 4 goes into 8 2 times. 2 times 4 is 8. Subtract. Bring down our little 4. 4 goes into 4 one time. 1 times 4 is 4. And we subtract to get 0. So now we know that this is 21 contestants. 21 contestants, 21 and 21. Okay, now 3/4 of them answered incorrectly. That's this much. This much is 3/4. 3 out of 4 is those guys. This is 1 out of 4 down here. So we need to know 21 times 3, and that's that second part I told you about. 21 times 3. 3 times 1 is 3. 3 times 2 is 6. So that means that these 3 come to a total of 63. Now, could you have added 1 plus 1 plus 1 is 3, 2, 4, 6. It comes to the same number if you add it or if you multiply by 3. Multiplying is just a fast way to add. Okay, so how many contestants guessed incorrectly? 63 contestants. Contest, A-N-T-S. It's like contest ants. Contestants. Okay, please get all that down. And we shall move on. What's our next star problem? Number 6. Now, some of you kids I know are very, very happy because some of you came to the Zoom homework help meeting in which we did all of the non-star problems that go with this problem. So we're kind of going ahead, guys. So if you want to join us and get some free answers, that is the thing to do, is join us for our math homework help meeting. It's more than just help with tricky problems. We usually have time to do a bunch of your homework problems. Okay, so we are on number 6. Number 6 says, in February, Fairbanks, Alaska has an average high temperature of 7 degrees Fahrenheit. That is very cold. And an average low temperature of negative 14 degrees Fahrenheit. How many degrees difference are these two temperatures? Okay, so we're talking about, if we're looking at like a scale, a thermometer, okay, we're talking about, this is 7 degrees. Let's just put 7 degrees right here, okay? And then we're talking negative 14. So it would be like, let's say this is where 7 is. 7, 6, 5, 4, 3, 2, 1, 0. And then another 14. Because we're talking negative 14. So if you think about how much it went down 7. and then it went down 14 more, but all negative, like negative. We were at positive 7 minus negative 14, we get negative 21 degrees, by the way. Degrees. Fahrenheit, that was Fahrenheit. Or you could have just said 21 degrees Fahrenheit. That would have been fine. Negative 21 degrees. Is that right? Let me double check. It says how many degrees difference are these two temperatures? So what's the difference? If we went down 7 plus another 14. We're not, I shouldn't put a negative there. We're just saying it moved 21 degrees. We're not claiming what the temperature is. Okay, I hope that makes sense. Okay, number 9 says 3 students each made a different estimate of the quotient 2,589 divided by 9. Okay, Paulo's estimate was 30. Carter's estimate was 300 and Allison's estimate was 3,000. Which student made the best estimate? Well, to figure out which student made the best estimate, we should probably estimate. So for number 9, looks like the board's still a little bit wet. Let me dry it a little bit better. So what would you estimate 2,589 to? Why don't you pause a second if you want to, and divide it by 9. That's the problem. 2,589 divided by 9. And one person said it's 30, the other 300, the other is 3,000. So let's see. Would it be 9 times something that's 1,000? Probably not, right? 9 times even 1,000 would give us 9,000. So that doesn't seem right. So let's see. Why don't we go ahead and try an estimate what we think we might use. Okay. Well, 2,589. What could we round that to? Should we maybe round it to, well, it seems to me like it would make sense to kind of think about what would be a number that would be divisible by 9. Like 9 times 2 would be 18. That's a little small. 9 times 3 is 27. So why don't we round it to 27 with 2 zeros? Just, it's a little bit high, but at least we get an idea. And look what we get. 3 times 9 is 27. 0, 0. I'm not going to do all the zeros. I'm just going to put it up there because I know that it's going to be there. And we get 300. So the question was, which student made the best estimate? And I would say it was Carter. Carter made the best estimate at 300. Okay, that was number 9. Let's go on to number 10. Number 10 says the first 5 odd counting numbers are 1, 3, 5, 7, and 9. Find the median of these 5 numbers. So the middle number of 1, 3, 5, 7, 9. Cross out the last 2, cross out that, and 5 is the median number. Median. There we go. 5 is the median. Okay, got that? I hope you're getting good at that. And you remember that median means most. No, said that wrong. Median means middle. Mode means most. Okay, number 11, write these numbers in order from least to greatest. Ooh, I love these challenges, like number 11. So for number 11, we have 7/4, We have 1.5, 1.5, 1 5/10 to be specific, and we have 14/10. Okay, so I would say that the best thing to do is to change these numbers to mixed numbers and maybe think about them on a number line. So here's a mixed number, 1 5/10. 1 5/10. Oh, wait, I don't want to change the original numbers, right? If I'm going to give it some equivalence, I should do it a little bit underneath it. 1 5/10. Ooh, tenths. Notice there's tenths there. Let's see. How would we change? What would we do with 14 out of 10? Why don't we try dividing? 14 divided by 10. How many times does 10 go into 14 one time? We have 4 left. Okay, so that's 1 remainder 4. Okay, think about this for a second. Yes, it's 1 remainder 4, but another way to write 1 remainder 4 is to put, here's a kind of a fun thing, is to put a decimal point, okay, and then it's 1 4 out of 10. So 1 4/10. That's really what that means anyway. So we can switch this to 1 4/10. Okay, or 1.4, or if there was no decimal, we would say 1 4 left out of the 10. So why don't we try something like that with 7 divided by 4? I'll do it over here to the side. 7 divided by 4. Let me check if you can see that. How many times does 4 go into 7? 1 time. We have 3 left, which is the same as 1 3 out of the 4 equal parts you've just divided. It's kind of a newer thing. That's one way to do it. 1 3/4. Okay. Or this is the same as 1.3, which is the same as 1 remainder 3. Okay. So let's think about these numbers on a number line. And we want least to greatest. So already we can see that 4 out of 10 is less than 5 out of 10. So let me just write 1 4/10 and then 1 5/10. Now we just kind of need to figure out what to do with, let's see, what to do with this one here. Okay, so 1 3 out of 4. Okay, 1 3/4. Would that be smaller than 1 4/10, or perhaps even larger than 1 5/10? Well, if you think about what these mean, you might notice that this is the same as 1.75. Would you agree? 1.75. Okay, and you might say, well, this is the same as 1.50 if you turn it into looking like money. This is the same as 1 4/10, or add a 0. And we find that this group here is the largest, right? These are all equal equivalents. Okay, so this one is actually the largest, 1.75, as we looked at these that we converted into decimals or to look like money. So 7/4 was actually larger than these other ones, so we're going to put that one last. Okay, now we have to go back to making sure that we put the original first numbers. Okay, so this was the original 7/4. Okay, I got that down here. Do I have 1 5/10? Let me switch this to look back like the original number, 1.5. So yes, I got that one. Do I have the original 14/10? No. So I'm going to write 14/10. Okay, and so this becomes the order that is my final thing. So this would be the thing. I don't have a yellow highlighter, but this would be what I'm going to highlight at the very end. This is the correct order. And when we put things in order, we put commas between them. We didn't really need those check marks. It was just to draw your attention, but we do need commas. Okay, so that's kind of a, feels like a little bit of a crazy problem. It is from lesson 92 that we just did a couple of days ago, comparing and ordering fractions. And it was a little bit of a tricky lesson, but I hope some of you are really thinking, okay, I got it. I hope most of you or all of you are thinking that, but don't fret if you don't. Maybe just pause it and just think about it. Try to turn them into mixed numbers. Maybe then try to turn them into decimals, whatever you can, so that you can compare those fractions. Okay, we are no longer on page 624. Of course, now we are on our next star problem, which is number 12. Number 12. It says, use the polygons below to answer parts A through C. Which of these polygons is a parallelogram? Parallelogram. Okay, a parallelogram has two sides, two different pairs that are parallel. So A is B, that rectangle. Okay, let's look at letter B. It says, which polygon or polygons, notice the S, appear to have at least one obtuse angle? Does A? Nope, I see a 90 and two acutes. Does B? Nope, I see 4 90s. Does C? I do see one obtuse. Yes, so C does have an obtuse angle. What about D? Oh yes, D has at least one obtuse angle. In fact, it has a lot more than that. If you take a look, angles that are open more than 90 degrees. Letter C, which polygon does not appear to have any perpendicular sides? Okay, A has perpendicular sides, B intersects, C has a perpendicular side, D. The answer is D. No perpendicular sides. In order to have perpendicular sides, you're going to need a 90-degree angle somewhere, and D does not have it. Every single angle is an obtuse, open further than 90. Okay, so that brings us to our next star problem, which is number 26. Number 26. It's from lesson 89. Draw and shade a circle to show that 8/8 equals 1. So we're trying to prove that 8/8 does indeed equal 1. All right, let's see, what kind of circle could I draw here? Okay, well, I'm trying to divide this circle into 8. So I'm going to divide it into 4 and then carefully divide it again to make every piece of what looks like a pie the same size. So 1, 2, 3, 4, 5, 6, 7, 8. Does 8 out of 8 give me like one whole pie? Yes, it does. So we have proved that 8/8 equals 1. That brings us to number 27, which says, the perimeter of the square at right is 40 centimeters. What is the area of this square? So if the perimeter is 40, what's the area of the square? this can get a little bit tricky because it doesn't tell you what the length and width is. We just simply find out that the perimeter is 40 centimeters. And now we're supposed to figure out, well, what's the area then? But it's a square, which is a regular rectangle. It means that this is the same as this and this and this. They're all the same. So what number would it have to be where it adds up to 40 centimeters? What would these each have to be? Could they be 5s? 5, 10, 15, 20? No. It would have to be 10s. So that's just that. This is where we use a little bit of logical reasoning, which is one of our strategies, right? Just like acting out the problem, etc. So we're going to use a little logical reasoning and say that these are all 10. Well, the area is a length times the width. So 10 times 10, which was 100 square centimeters. Okay, so that is number 27. Number 28, no, not 28, number 29 says compare 0 and 25 hundredths to 0 and 250 thousandths. Guys, that is exactly equal. All they did was put a another 0 into 0.25. They added a 0, but they're equivalent. They're equivalent. So B says to compare 25 cents to 25 cents written another way. Guys, for 29, you have to put A is equal and B is equal, but write out all the numbers, please. So I'll just give you that verbally. Number 30 says Madison had $100 in the bank. Okay, she wrote a check for $145. Ooh, she wrote a check for more money than she actually had in the bank. It says, what number represents the balance of her account? So she had 100, and then she spent 145. Bad girl. No, don't do that. So what did she have? That would be like on a number line. If here's 0, here's 100, right? She spent not just 100, but another 45. Right? 100 down to 0, and then another 45. So what does she have? She has negative $45. And this is your answer. Negative $45. We don't need a decimal point because we're not going to put the cents. So negative $45. Okay, well that's your whole lesson 94 and all the star problems. You guys know you can get a hold of me if you need me, and I will see you tomorrow. Take care.